Okay, so to begin with, we're going to look at now the law of sines type of problems that we learned how to do. So we're going to solve some triangles here. So I want to remind you that the law of sines goes like this. If you have any triangle, it can be a right triangle or an oblique triangle, just a triangle without a right angle, you want to know the naming convention, C and C, capital A, little a, capital B and little b. Sometimes I'll use, alpha and A, beta and B, and gamma and C. Okay, just kind of interchangeably. But the law of sines goes like this. You pick an angle, you do the sine of that and divide it by the opposite side, and then formulate that ratio like this. Okay, you can also do that backwards. You can do the reciprocals of everything. You just have to be consistent in the way you do this. So this is the law of sines formula written in the two ways that it can be written. Okay, so what I would do on this one, we're going to just kind of identify what we're given in this problem. So it looks like we're given that angle B is 50 degrees. Angle A is 80 degrees, and this would be side C would be equal to 20. So that's what we're given in this problem. What we're going to try to find is the remaining parts of the triangle. So we have to find angle C, we have to find side A, and we have to find side B. Okay, so that's what we're looking for, is those things right there. So you got to start somewhere. Generally, if you're given three parts of a triangle, then you can find the rest of it. So step one, the logical thing to do would be to find angle C, since we know these two. So all you got to do on that to find angle C is just to take 180 degrees and subtract off the 80 degrees minus the 50 degrees. So that would be, let's see, 100 minus 50, that'd be 50 degrees. Okay, so we now have C is equal to 50 degrees. So that's easy enough to find, right? So I'm going to just put that in my diagram like that then. Okay, now we're probably ready to use law of sines. So we move on and we got to decide what we want to find. So we can either find A or B. Let's just start with finding A. Now the way I like to do this is match up four numbers that will satisfy the law of sines. So we have A and we know the angle. Now we have no choice. We can't do B and 50 because we'd have an extra unknown. So we have to match that up like that. So if you set that up with law of sines, I always put the unknown in the upper left-hand corner of my proportion. So I'm going to say A over the sine of 80 degrees, and then that will be 20 over the sine of 50. So I'm being consistent. I'm putting the angles on bottom and the sides on top. So that should be a valid law of sines proportion. Now all I got to do is solve this, so I just multiply both sides by sine 80, and then I get my calculator out. Okay, so that will give A equals, and then we just need to compute this on the calculator. Now I need to make sure that I'm in degree mode, so when you're working out problems, always pay attention to the mode you're in. All right, so we got to be in degree mode. Then I'm just going to do 20 times the sine of 80, and then I'm going to divide that by the sine of 50 degrees, and I'll round that off probably to one decimal. So it looks like that side is going to be about 25.7. So now we know that side A is about 25.7, so we're done with that part. Okay? All right, now we got one more part to find, so now we can kind of do the same thing for side B. So I'm going to erase some of this. Okay, so now we're tasked with finding B. So the way to find B is we got to match B up with the opposite angle, and then I would still recommend that you use 20 and 50. Okay, so let's set that up. We'll say B over the sine of its opposite angle is equal to 20 over its opposite angle, like that. Okay, well, it's pretty obvious what the answer is. The answer's got to be 20. But you could go ahead and do this if you wanted to. I'll explain. I mean, this is something over sine 50 20 over sine 50. The only thing that's logical is b has to be 20 also. But if you didn't see that, you would solve just the same way I did the last problem, like this. So if you don't believe me, and I'd go, well, you can do this. Look at this. That just cancels out. Okay, so you get b equals 20. Okay, so the final answer to that problem would be b equals 20 degrees then. Okay, so the other thing I like to show students on, this problem is now solved, is how easy it is to tell you're right on your calculator. So we got C was 50, we got side A was 25.7, and we got B is 20. So all you really got to do on a calculator to tell if you're right is just, start somewhere, pick an angle. This is the way I usually do it. It's just pick an angle. Let's start with 80 degrees. So if I do the sine of 80 and divide by the opposite side that we found, okay, I'll just get what that is. Now pick another angle. Let's go sine 50, and let's divide by the opposite side, like side B. So sine of 50 over 20 should be the same thing, or close to it. So it's close to it. And of course, you'd be doing the same thing with sine 50 over 20, so there's no point in doing that again. So that's how simple it is to check your answer on a problem. It's just use law of sines on all the angles and opposite sides that you know on your triangle now. Okay, so now let's go to this one. This one is just, if I ask you something without a triangle, then it's beneficial to draw a triangle. You don't really have to do a triangle, but I'm going to choose to do that. So here's my gamma, which is given as 27.3 degrees. So the side opposite is C, so that's 8 inches. That's given. I'm going to call this angle alpha, which we don't know, but we do know the side opposite is 12.5 inches. And then that would leave this with being beta and B. So what we're given in this problem is we're given angle gamma is 27.3 degrees. We're given side A is 12.5 inches. And we're given side C is 8 inches also. All right, so what are we going to find? We need to find angle beta, angle alpha, and side B. All right, so let's kind of figure out where we want to start on this. Now, we only know one angle, so we can't find the other angles unless we use law of sines. So let's kind of decide how we're going to do this. So first of all, in order to use law of sines, you always have to have an angle and a side opposite, and then any other part of the triangle. So we're going to have to use this. We don't have enough information to figure out beta and B yet. We're kind of forced to start this way. So the law of sines ratio would go like this. I'm just going to set up a ratio. Again, I like to put my unknown in the upper left-hand corner of my proportion. So I'll say sine of A over the length of the opposite side. Then I'll do sine of the angle that I know, 27.3, divided by its opposite side, which is 8. So this would be the law of sines ratio that you would solve. So what I'm going to do is multiply both sides by 12.5. Then I'll go to my calculator. Okay, so what I'll end up having is sine of alpha. Then I need to go to my calculator to just crunch out this value on the right side. So I would just go 12.5 multiplied by sine of 27.3. Get that established, and then divide by 8. And then that would give this. Okay, then I can just do the inverse sine. And you don't necessarily have to write all this out because you're doing this all on the calculator anyway. So what you're doing is the sine of that number. Well, you can use the memory key, which is stored under ANS on a TI-84, 83 type calculator. So I can just go inverse sine, second sine. Then I can go second negative to get that answer. That just automatically plugs that in. So you would end up getting alpha is about, let's round that to 45.8 degrees. Okay, so we've got one of the three parts that we're looking for. We're done now with alpha. Now I can kind of write this in. Alpha is 45.8. Now we just need to move to the next stage. So it should be easy to find angle beta. So angle beta is just going to be 180 degrees minus the two angles we know, 27.3 and 45.8 degrees. So I can crunch that out on my calculator and work that out. Okay, so I'm just going to have 180, subtract 27.3, and subtract 45.8. Okay, when I do that, it looks like I'll get angle beta is about 106.9 degrees. So that gives the second answer to the problem. So we only got one more part to find then. So we got our angles alpha and beta. All right, so we got one more thing to do. So we got our angles. So it looks like the other thing we got to do is we got to find B. Okay, so the third thing is we need to find side B. Okay, so we're going to set up our law of sines ratio here. Now I'm going to highlight like this. I've got B and I have to match it up with the angle. And then we could either do C and gamma, or we could do A and the alpha we found. I usually tell students to just use whatever was given in the problem in case you made a mistake somewhere. So I'm going to go like this. I'm going to do the unknown B over the sine of its opposite angle, 106.9 degrees. Then I'm going to match up the 8 over the sine of 27.3. Okay, so to solve this, I just need to multiply both sides by sine of 106.9. Okay, and then go to my calculator. All right, so I'll do that to wrap up the problem. So I got side B is going to be 8 times the sine of 106.9 and divide by the sine of 27.3. Okay, so we got that. So we're going to end up with beta is about 16.7. Okay, so that would be the answer to the problem. Those are the three parts. We got alpha, beta, and then we got side B like that. Okay? All right, and you could check that by just formulating the ratios around the triangle to show you're right, as well as showing you in the previous problem. All right, so those are two typical law of sines problems. Okay, now we're going to look at a couple of word problems that involve law of sines. So I'm going to go ahead and do this. Okay, now these word problems, sometimes you have to go through several things before you can get the answer. Basically, I like this problem because this is Colorado where we live. So the Royal Gorge, the famous bridge that goes over the Arkansas River, is said to be the highest bridge in the world. I didn't know that. I guess that's right. So we got to try to figure out what that height is given these two angles and the distance between the edges of the bridge, the top of the canyon. So we're going to have to kind of formulate what we're going to do with triangles here. So we don't, I assume this is probably a right angle. If you were measuring the height of something, that you want that to be a right angle. So we really have, kind of in looking at step one on this problem, well, we have two right triangles. So we have this angle is, and then 69.2. We could find that angle if we need to. Then we have this other right triangle, which has a 65.5 degree angle, and we could find that angle if we needed to. Okay, well, we're trying to find the height, so ultimately we got to find this side of one of those two triangles. So we're going to have to probably use law of sines in here somewhere just to find the side. Okay, so to begin with, let's kind of think about what we got going on here. So hold on just one second. Got somebody knocking on or calling me. Okay, so ultimately at the beginning of the problem, these two right triangles aren't going to do us much good. The only thing that we know is we know a side of the big triangle. So we'll probably go back to this step one in a minute. Let's just kind of consider what's happening on the big triangle. So the big triangle, that's where we have this side right here as 880 feet. Then we have these two angles here. We have 69.2 and we have 65.5 like that. Now we can only use law of sines if we know the opposite angle. Well, we can figure out that opposite angle. We can actually figure out these two angles right here. So this angle in this right triangle would be 180 minus 90 minus 65.5. Okay, so I'm going to go ahead and start this way. This is kind of what I'm seeing in this problem. So I'm going to do 180 minus 90 and then minus 65.5, and I'll record what that angle is. So it looks like this angle is 24.5 degrees. I can do the same here. I can do that angle as 180 minus the 90 degrees minus 69.2 degrees. So I can go ahead and do that. Okay, so let's do that. That looks like 20.8 degrees like that then. All right, so I got that. So actually that would give us enough information to figure this out. That would just be those two angles added up. So this angle would be 20.8 plus 24.5 degrees. So let's do that. Okay, so that would be now a 45.3 degree angle. Okay, so now we have enough information to figure out the law of, to use the law of sines to find a side. So this angle is 45.3 degrees. Okay, so let's kind of take it from here. Let's just pick a side. It doesn't matter which side we call this. I'm going to call this side, I guess, X. And then we would have enough information to find X. We could put X over its opposite angle, and then we could put the side we know over that. That's enough to figure out that side X by law of sines. So we would say X over 69.2, the sine of 69.2 degrees. That would be equal to the 880 over the sine of its opposite angle like that. All right, now we got enough information to solve this equation, of course, so we can multiply both sides by the sine of 69.2 degrees. Okay, wipe that out. Now we can go to the calculator and we can get what that side is, and then I can show you how to finish up the problem. So we go 880 times sine of 69.2, close parentheses, then divide that by the sine of 45.3. Okay, so that would give me, that side would be 1157.4 feet. Okay, so see, we know what that is now, so I'm going to fill that in. That side is 1157.4 feet. Okay, now what we could do to finish up this problem is you could go to this right triangle. You could go to this second right triangle here, and then you should have enough information to solve this. So what you have is you've got a right triangle with an angle of 65.5, another angle of 24.5, and now you have the hypotenuse as 1157.4. So we just need to find that height. And there's enough information to use basic right triangle trig, and there's more than one way to do this. So what I'm going to do is look at this information here, and we're just using right triangle trigonometry now, so we don't need to use law of sines on this, although you could. There's enough information to do it that way too. What we would have here is I'm just going to say it looks like the sine of 65.5 degrees is opposite over hypotenuse. Well, opposite is h, what we're trying to find, and then the hypotenuse is 1157.4. So if I multiply both sides by 1157.4, then I'm going to get h is 1157.4 times the sine of 65.5, and then that'll give you the answer. Okay, so I'll just do that, 1157.4 for that hypotenuse times the sine of 65.5, that was a given angle, That should give the height. So this height is about, we'll just say 1,053 feet. It doesn't say how to round, so I'm just going to say about, let's round to one decimal, 153.2 feet. That's a good problem. There's a lot of things to think through on that. There was kind of three major calculations that we had to do. And I'm sure there's a different way to look at that problem. That's just kind of what I was seeing in the beginning. Okay? All right. Let's move to the second example here. And this one, now we got to kind of read the problem and do a diagram. This says, at the same time, Tom and Alice measure the measure of elevation to the moon while standing 3 kilometers apart. Tom's angle of elevation was 49.8974. Alice's was a little smaller. And that's all they give you. They say find the distance. How far was the moon from the earth when these measurements were obtained? Interesting problem. So let's draw a picture. Here's the moon. And, here's the earth. Okay, like that. And these two people are so close together that we can just assume that this is, a straight line here. So I'm going to just basically take a couple of distances here. So I'm going to make really a right triangle out of this to begin with. And this might not be drawn to scale. So this is what we're trying to find, is that distance from the Earth to the moon, and that straight line distance like that. So that's what we're going to find. Well, the two people are here, so we have, let's see, we have Tom, who's going to have a little bit bigger angle of elevation. Then we got, who's the other person? Alice. So she has an angle of elevation. All right, so I'm going to just kind of sketch this out like this, again, using my nifty tools here. Okay, to kind of get us a triangle set up. And then we'll kind of talk about what we're given in this problem. So that's kind of the way I see this, is I see that we were given that Tom's angle of elevation to the moon was 49.8974 degrees, and Alice's was a tad bit bigger because she's closer in, so that would be 49.9312 degrees. Now you have to reason out, this angle's bigger than that. The closer you get from that measurement, the bigger the angle's going to get. But the measurements are so close to each other, that's because the moon is really far apart. So we have that. The other thing that problem said is Tom and Alice are 300 kilometers apart. And that's all you're given in the problem. I'm making a right triangle out of this. Then we have a couple of oblique triangles right there. So we need to see ultimately how we're going to find D. So let's see, on this one, this triangle, this right triangle right here, we know two angles. We could figure out this angle, but it wouldn't do us any good in finding T yet. So we got to work with this side. The only length of a side we have is this right there. So really, I think what we'd have to do here is ultimately we would like to find this angle here. We'd like to be able to find that angle and that angle there. And we have the ability to find all that information right there. Okay? So what I'm going to do in the beginning of this problem is I'm just going to find this angle here, which I'll just call alpha. So alpha, since it's a straight line, would just be 180 minus the 49.9312 degrees. And that'll give me the angle next to that, and then that'll give me enough information to figure that angle at the top of that oblique triangle. So I'm going to go 180 and then minus 49.9312, and then I'm going to record that. So that angle alpha is about 130.0688. So that's what that angle is. Okay. Now I can find this angle, which is beta, which I think we need if we're going to use law of sines. So the second key thing I'm going to do is this calculation here. We just need to do these two angles minus 180. So beta is going to be 180 degrees minus the 49.8974 minus that angle alpha, which we just computed to be 130.0688. So that would give that angle beta like that. So I'm going to do that on the calculator, 180 minus the 49.8974 that you were given minus the 130.0688. All right, so that would give a real small angle. And that makes a lot of sense to me, is because we're measuring, the distance to the moon, so that's a tiny angle right there. So what I'm going to do in my step 3 is I'm going to look at this oblique triangle. Okay, this is the oblique triangle right there that I'm trying to highlight in blue, and I'm just going to sketch this out. It's not going to be perfect, but here's what I know. I know that this is 300 kilometers. I know this angle is 49.8974. I also know this angle we just calculated as 0.0338. Okay? Now what's going to happen on this is we could figure out this hypotenuse. So I'm going to call that hypotenuse. That's not a hypotenuse. That's just it's not a right triangle, so it's not a hypotenuse. I can call it whatever variable I want to, though. So I'm going to call this y, and notice on here I have enough information. I have an angle and the side opposite. Then I have an angle and the unknown side opposite. So those three things right there are going to allow me to use law of sines. So if I do this, I'm going to say y over the sine of 49.8974 degrees is equal to the side 300 that I was given over the sine of 0.0338 degrees, like that. So I've got the side over the sine of its opposite angle, the side over the sine of its opposite angle. That's enough information to find y, and then we'll be close to being able to finish up this problem. So I've got, I can multiply by the sine of 49.8974 degrees, sine of 49.8974 degrees. That'll cancel out. Now I'll go to the calculator and I'll have the value of y there. Okay. So what I'm going to have is 300 times the sine of 49.8974 and divide that by the sine of, this will be a big number, 0.00338. Did I put that in? I put that in wrong. So it's like 0.0388. Okay, now I think I've got everything in right. And that should be a big number, like I expect. So that is 338,853, let's just say 0.8 kilometers. Well, we expect that to be a big distance because that's the distance Alice is from the moon. Okay? So what we have now when we go to step 4 is we're going to look at this right triangle. So I'll just kind of focus on this right triangle, and we have enough information to find D now. So we have this right triangle. D is what we're trying to find. We have this angle is 49.9312, and we just figured out that y was 338,853.8 kilometers. So that's enough information to use right triangle trig to find the value of D. So if you look at this, in relation to this angle, we have a side opposite over hypotenuse, so we're going to use the sine. So we'll have the sine of 49.9312 degrees equals the side opposite D over the hypotenuse. Okay, that's enough information to find D. So you just multiply both sides by the 338,853.8. So you would have 338,853.8 times the sine of 49.9312. Then we got it. Okay, So let's see what that is. It'll be a little different than Alice's distance. It'll be a little smaller. So we just go, take this number, 338, and then 853.8, and then we multiply that by the sine of 49.9312 to get the final answer of the problem. Okay? That doesn't make sense. Did I put that in right? Yeah, I got it in right, I think. 338, 853. Okay, yeah, all right. Okay, well, this is right. So what I found on there then was this. Now, the thing is, Alice's distance is I thought they were going to be closer, but it's because of the value of the angles of elevation. It's a little further off than I thought it would be, but we would get 259,315.3 kilometers would be the final answer of that problem. Okay, so that is your final answer right there. And the reason for that is we don't really know how far this point is from here, but because of the value of that angle, that kind of determined how far apart Y and D were. But I knew D was going to be smaller because it's a straight line perpendicular distance from the moon to the earth. Okay, so that's it. All right, let's go to the next page, and we're going to do some area triangle, and then I'll post the next part of the video just going over that. So what we have is when you learn the area of triangle formulas, it goes like this. And I want to show you how you can remember this. You can do these problems without even looking up these formulas. But there's three versions of these formulas. And they're all side angle side. So one way to look at it is the area of the triangle. It's always 1/2 the product of the two sides times the sine of the angle in between. So if you're given a side angle side case, you just do 1/2 product of the two sides times the sine of the angle in between. The other way you could do this is 1/2 times, and then I'll highlight this like this, ABC. Okay, side angle side. So what you would have there is you would have 1/2 AB sine of C. Or the third way to do this would be like this. You could go side angle side like that, so you would get 1/2 AC sine of B. So notice this kind of has a nice pattern. You have an angle and then two sides that are not opposite A. An angle and two sides not opposite C, and so forth. So you can refer to those formulas if you want to, but I think it's better off to not even memorize those formulas, just memorize the structure. I mean, you can do, if you understand the structure, you can create those formulas the way I just showed you. But really in this problem, you're given side angle side case there. So what you would do is the area of that triangle is just going to be 1/2 the product of those two sides times the sine of the angle in between. And you just go to your calculator to get that put in then. And you can put it in like this. You could say that's 0.5, that's 99, that's the sine of 58 degrees, and that would give you the answer of the problem. Okay, so I'm just going to put that in. 1/2 is 0.5 times 99, and then times the sine of 58, and then that should give you the area of that triangle, which is about 40, let's just say 42. So we'll just say it's about 42 square units. All right, if you wanted to round to one decimal, you'd end up just getting 42. Okay? All right, so that's how you do that. The next problem, let's see what we're given. Now, you could, you might not have enough information on this to do it as easily as we did the previous problem. I'm going to start this problem by just drawing a triangle, and it might not be drawn to scale. So we have alpha is 52 degrees. I'm going to call this beta as 35 degrees. And then I'm also given A is 12 inches. Okay, now that would force this to be gamma if you're using Greek letters. That would force this to be side B, and that would force this to be side C. Now we're not given a side angle side case. So what we're going to have to do on this is, if we already know A, it would be nice if we could find C, because then we would have side angle side there, like that. So it'd be kind of nice to get that. We could also get this angle, and then we could get B, but we got to get side angle side case. So there's several ways to do this. I'm going to start by doing, let's just use law of sines to find this part right here. So we have an angle and a side opposite. That means I can use law of sines. Then I can match up like there. So once I find that, side B, then I'd have a side angle side, because I can also find that angle there. So that's one way to do that. That's just what I'm seeing here. So let's go ahead and find side B. So we're going to set up our proportion. So I'll have B over the sine of 35 degrees is equal to 12 over the sine of 52 degrees, like this. Okay, so what I can do is multiply both sides by the sine of 35. Okay, then I can go straight to my calculator. So I would get B is about 12 sine 35 degrees over the sine of 52 degrees. Okay, so I'll use the calculator to crunch that out. So 12.5 times sine 35 degrees, and then divide by the sine of 52 degrees. And that will give me that B is about, let's just round to one decimal and say 9.1. Okay, so now I'm going to throw this in here. So I've got 9.1. So notice that I've got two sides. Now I need to just find that angle in the middle. So probably the second thing I would do is just crunch out this angle. That angle would be 180 minus 52 minus 35. And then we'd have enough information to use our area of a triangle formula. So I do 180 minus 52 minus 35, and then that would give me a 93 degree angle. So basically what I have now is I got everything I need to know. I've got side, angle, side. So now it's easy to find the area of the triangle. So I finish up the problem. The area is going to be equal to 1/2 the product of those two sides, 12 and 9.1, times the sine of the angle in between. And you can just go straight to your calculator and do this. So you can do it lots of ways. 0.5 times 12 times 9.1, and then times the sine of 93 degrees. Okay, like that. And that will give me the approximate area. Round that to one decimal, I guess. So we'll have about 54.5. And you do want to write your units. That is square inches. Area is in square units. All right, so that'll wrap up kind of the review for law of sines. So I'm going to post a video on this part and then record one more part.